Today we are starting in the next chapter, that is atoms and molecules. And the first topic in this chapter is laws of chemical combination. Laws of chemical combination. When chemicals are combining, they follow certain laws, and those laws are known as laws of chemical combination. So from this statement only we get the meaning of this statement. Laws of chemical combination means whenever substances they react chemically, they follow certain laws, and those laws are known as laws of chemical combination. Whenever substances react chemically, they follow certain laws. These laws are called laws of chemical combinations. Now, two laws we have to cover in class 9. These two laws of chemical combination are, first of all, we are taking up the law of conservation of mass. Law of conservation of mass. The statement of this law, from again the statement from these words is clear. Mass is conserved here. Which mass is constant here? Whenever the chemical reaction takes place, there will be reactants and there will be products. Substances which are reacting are reactants, and new substances that we get in a chemical reaction are known as products. So this law states that in every chemical reaction, total mass of the reactants is always equal to the total mass of the product. Total mass of the reactants is always equal to the total mass of the products. This is one statement. There is another statement for this law, that is mass can neither be created nor be destroyed. Mass can neither be created nor be destroyed whenever a chemical reaction takes place in a chemical reaction. Now, to understand this law, I'm taking one example. Let's say we're taking here mercuric oxide. Mercuric oxide. 100 gram, let's say, mercuric oxide is taken. And we heat this mercuric oxide. On heating, mercuric oxide will break to form mercury and oxygen. So we have taken mercuric oxide, we will heat it, and let's say we have taken 100 gram of this. And on heating this, we collect the mercury formed after reaction. This is 92.6 gram. And oxygen also we will collect. This is 7.4 gram. Now see, the mass of reactant is 100 and mass of product is 92.6 plus 7.4. This is also 100. So mass of reactant is equal to the mass of the product. There is no creation or there is no destruction of the mass here. Mass remains constant whenever a chemical reaction takes place. Now, one activity to understand this. In this activity, we are demonstrating the law of conservation of mass. Experimental demonstration of law of conservation of mass. So the activity is, for this we are taking a flask, we will take here. This is called conical flask. In this flask we will take sodium sulfate. What we will take in this one is sodium sulfate, and in the test tube, this small tube, this is tube, test tube, or actually this is called ignition tube. So we take a ignition tube, and this ignition tube we will fill with sodium sulfate, we'll take in this. And in the flask we'll take here barium chloride. So the solution here is sodium sulfate, and this is barium chloride, and this tube with a thread we will hang in this. It will not be like this, with a thread only we'll hang it, and then we'll cork it. We'll just close it. And after closing this, what we will do is we'll tilt this flask. When we'll tilt this, what will happen? The two solutions, they will mix up with each other. So what we have to do here is mix the contents. How will mix the contents? By tilting the flask, or by tilting this ignition tube. On tilting this thing, the two solutions will mix up and they will react with each other. The reaction that takes place is this reaction I'm writing. This is actually sodium sulfate reactant, and second reactant here we have taken is barium chloride. On tilting this flask, the two solutions, they will react with each other, and as a result of this, what we will get here is barium sulfate, which will be in the form of white color precipitates, and plus we will get sodium chloride. So now here in the flask here, this tube will be mixed up here with the two solutions, and as a result of this we will have here, let's say this one now will be your products barium sulfate and sodium chloride. Now first of all, when we'll set up this apparatus, we have to weigh this. So when we weigh the flask, let's say the weight comes out to be equal to W gram. And after tilting, the two solutions will react with each other and the products will form barium sulfate and sodium chloride. Now again take the weight of this flask and we'll see that this also comes out to be equal to W gram. If this is 100 gram, this also will be 100. If this is 50 gram, this also comes out to be 50 gram. So from this activity, this is clear that the law of conservation of mass holds true for any chemical reaction. So the experiment was, we will take approximately 20 ml of barium chloride in this conical flask, and then we take a sodium sulfate solution in a test tube. This small test tube is called ignition tube, and we'll hang this test tube in a conical flask with a cork. This thing here is a cork here. This is cork, and this is conical flask. And now we have to weigh this flask. After weighing it, tilt the flask. After tilting, what will happen? The two solutions will get mixed up with each other and a chemical reaction will take place. When the chemical reaction will take place, after that again we have to weigh the flask. So on mixing the two solutions, when the chemical reaction will take place, how will come to know chemical reaction has taken place? Like I told you, this one is in the form of white precipitates. So something new is forming here. That means chemical reaction has taken place between the two. And the mass of the flask before the reaction and after the chemical reaction comes out to be same. So this verifies the law of conservation of mass. After law of conservation of mass, next law that we have to cover is law of definite proportions. Proportion means ratio. Definite ratio. Ratio is constant. Or this is also called law of constant compositions. Law of constant compositions. Now, first of all, the statement of this law. This law states that whenever we take any pure chemical compound in which there are no impurities, just a chemical compound when we take, like for example, we have taken water, it always contains same elements. Like water is always made up of hydrogen and oxygen. So first part of the statement is this, that any compound we take, it is always made up of same elements. Now second part of this law is, and these elements, they always combine together to form that compound in a same fixed proportion by mass. They always combine in a same fixed ratio by their mass. So ratio we have to take of their masses. So for example, to understand this, I am taking water only. Water, we are taking pure water. So pure water that we obtain from any source, whether we take this water from river or from a well, from the rain or tap water, or from any country we are collecting this water, is always made up of same elements, and these elements are hydrogen and oxygen. And next part is hydrogen and oxygen, they always combine in a fixed ratio, that is 1:8 by mass, to form water. This means if we are taking 1 gram of hydrogen, we have to take 8 gram of oxygen. Then only these two combine and they will form which compound? They will form water. So this is the law of definite proportion. Definite ratio is there. This ratio is always definite. Whenever the compounds, they are combining, the ratio elements they are combining to form a compound, ratio of those elements will always be constant. Law of constant composition. Constant composition means this compound water is always made up of hydrogen and oxygen. Their composition is always fixed. So this is the law of definite proportion or law of constant composition. After this we have Dalton's atomic theory. Dalton's atomic theory. The main points of this theory are, there are the points in this theory. First point is, any matter we take, matter is always made up of very small particles, and these particles are known as atoms. Matter is made up of tiny particles, and these particles are called atoms. For example, if I'm taking this matter, some article we have taken, and this is actually made up of very, very small particles, and these are called atoms. Second point is, atoms actually are indivisible according to this theory. These atoms, they cannot be broken down further to form the more particles from it. So this is indivisible. This cannot be created and this cannot be destroyed. Third point of this theory is, atoms of given element are identical. Atoms of given element are identical. Element atoms are identical in their mass and in their chemical properties. They show the same type of chemical properties. Like for example, if I take an element like magnesium, for example, this is magnesium element. This is made up of atoms. These atoms of magnesium, all these, they are identical in their mass as well as in their chemical properties. Fourth point is, if we take different elements, like one I'm taking is magnesium, another one I'm taking is oxygen, the atoms of different elements are different. Like these are atoms of magnesium. For example, these I'm taking as atoms of oxygen. They are different. Their masses are different and their chemical properties are also different. Next is atoms combine, like hydrogen and oxygen elements I'm taking these. The atoms of these, for example, atom of hydrogen is this, and atom of oxygen. I'm drawing like this. The atoms of these elements, they combine, and they always combine in whole number ratio. Like hydrogen and oxygen combine to form a compound, that is water. Two atoms of hydrogen have combined here and one atom of oxygen have combined here to form this compound. So fifth point of this theory is atoms combine always. How the atoms are combining? They always combine in a small whole numbers to form a compound. And sixth point of the theory is the relative number and kinds of atoms are constant in a given compound. Like this compound we are taking, how many atoms of carbon will be there, how many atoms of oxygen will be there, that will always be constant. So to form carbon dioxide, there should be one atom of carbon and two atoms of oxygen. So this ratio also always remains same for a given compound. And if we take water, then two atoms of hydrogen and one atom of oxygen combines to form this compound water. So these are the points of Dalton's atomic theory. And repeating these points, first point of theory is any matter we take is made up of very, very small particles. These are called atoms and these are not visible to naked eye. And these atoms are indivisible. These cannot be broken down and cannot be created. These atoms, we cannot break them. They are indivisible in nature. Atoms of same element are identical in all respects. In their mass, chemical properties, in all properties, they are identical. But if we take different elements, their atoms, they have different masses and different chemical properties. Atoms of different elements, they combine to form compounds. Atoms of different elements, when they combine, what they will form? They will form compound, and when they are forming compound, the atoms, when they are combining, they always combine in a fixed whole number ratio. And how many atoms of each element are here in a compound? That ratio will also be always constant. So this is about the Dalton's atomic theory. Now we are doing the numericals based on the law of conservation of mass. This is the first numerical. In a reaction, 5.3 gram sodium carbonate reacts with 6 gram of acetic acid. These two substances are reacting, so these are reactants. And products were 2.2 gram carbon dioxide is forming, 0.9 gram of water is forming in this reaction, and 8.2 gram of sodium acetate is forming. These are the products because these are forming. Show that these observations are in agreement with law of conservation of mass. We have to tell that these observations that we have, the masses which are given, these are according to law of conservation of mass. And the reaction is also given in a question. The reaction is, and if the reaction is not given, we have to write the reaction. Sodium carbonate is a reactant, we know, and acetic acid. These two are reacting, and what they are forming is carbon dioxide. Then they are forming a water, H2O, and sodium acetate. We can write the reaction in words here. This is given. So we have to show that this data is according to the law of conservation of mass. So answer is, we take the chemical reaction first of all. In chemical reaction, sodium carbonate, again I have to copy this chemical equation because first thing is we have to write this chemical reaction when we are solving these kind of numericals. Carbon dioxide, water, and sodium acetate. What is law of conservation of mass? Law of conservation of mass is that mass of reactant is always equal to the mass of the product. So that only we have to check whether we are getting the mass of reactant equal to the mass of the product or not. If these will be equal, we say this is in agreement with law of conservation of mass. So sodium carbonate mass is how much given? 5.3 gram. We write it here. Acetic acid is how much? 6 gram. Carbon dioxide is 2.2 gram. Water is 0.9 gram. And sodium acetate is 8.2 gram. So then mass of the reactants is equal to 5.3 plus 6 grams. This is equal to 11.3 grams. Now come to the mass of products. Product mass is 2.2 plus 0.9 plus 8.2. Add these, this also comes out to be equal to 11.3 grams. So mass of reactant is coming out to be equal to mass of the product. So what we'll write, since mass of reactants is equal to the mass of the products, thus the data is in agreement with the law of conservation of mass. So all steps I've written, and when we are writing the solution, it has to be written this way only. All the steps that we need to solve the numerical, they have to be there. So first equation is required, mass of reactant is required, mass of product is required, or both the masses are equal. So we have to write in words, since the masses of reactants are equal to masses of products. So this data is in agreement with law of conservation of mass. Moving on to the next numerical now. One more numerical we are doing based on this law. Hydrogen and oxygen, they combine in the ratio of 1:8 by mass. Now here ratio is given, so this is according to the law of definite proportion. To form water, same example we have done in law of conservation of mass. Hydrogen and oxygen, whenever they combine in a ratio of 1:8 to form a compound, that is water. Now next part, see. What mass of oxygen would be required? How much mass of oxygen is required if we take 3 gram of hydrogen? For 1 gram of hydrogen, we need 8 gram of oxygen. And our question is, if we take 3 grams, so unitary method we have to use. So answer is, first of all, we mention that ratio of mass of hydrogen and oxygen, ratio of hydrogen mass and oxygen in water, in case of water compound, that is given in the question is 1:8. This means 1 gram hydrogen combines with 8 gram of oxygen. This is 1 gram hydrogen combines with oxygen equal to how much? 8 grams. And in the question it is given, we are taking 3 gram of hydrogen. So if 3 gram hydrogen we take, how much of oxygen is required? So just a unitary method, 8 into 3, this is equal to 24 grams. So 24 gram of oxygen is required to combine with 3 gram of hydrogen. So this